Hi my friends, today we model this part, angular profile with punches, which it looks, as you can see, having some features like this one and this one as special features. The drawing is this one with all dimensions here, made by me, of course. And you see a sheet metal part here. What do we know about sheet metal parts? Well, we know that when we select the template sheet metal, millimeters in our case, we can use the manage and select FX, or if you place it on this row, you can select it from here. And we find a number of specific parameters for this kind of parts, sheet metal parts. The most important is the thickness. The default value for the thickness is 0.5 millimeters. We can use the sheet metal defaults tool to change the thickness. For instance, to make it 2 millimeters. Okay. Then we see here the changed value of the thickness and, of course, with effects to all other parameters from the table. Good. This is what we know about the sheet metal parts. In our case, with this part, we don't start by using the sheet metal template. We have dimensions here. As you can see, 30 millimeters is this dimension and 30 millimeters is the other dimension. Roughly this flange and this flange are equal with the dimension of 30 millimeters. Good. And what should we do? We use the standard millimeters template. We start from the XY plane, where we create a square with 30 tab 30 millimeters dimensions. We extrude this square symmetrical from the base plane at a value of 155. Okay. You see, we created now this basic part of our sheet metal part. Now we use the same plane XY to create a sketch with a line. F7, a simply line from edge to edge, tab 45. You see, the line is connected with these two edges, and we have to apply only one dimension. That dimension is 16. Okay, let's apply the 16 distance from the line to the corner. Finish sketch. Next step is to create an axis by using 2 points. Create point, and one is the first end of that line and the other is the other end of the same line. Now we have here an axis, you see. We use this axis to create a plane which is perpendicular on this axis and containing this point. This plane we use to create a closed contour and to extrude that contour. Line to the point and to the edge. 90 degrees is the angle. And we didn't project the point to use it as a reference. F7 to see inside. The point is over this point. And we make equal these two lines. Now we have a closed contour by using the projection of the edge. Extrude this, cut, not join, through the part. Okay. See? We hide the sketch, we hide the plane, and we also hide the work axis. We don't want them to be present in our nice image. Good. Now we have to use what we know from the sheet metal part parameters. If a part has a dimension of 2 millimeters, a thickness of 2 millimeters, then the external radius is twice 4 millimeters. 4 millimeters also here, here, and all this, plus this one, which is an internal radius, which is 2 millimeters. Okay, let's create physical aspect for a stainless steel, and now we have the cut with the bending, the virtual bending fillets. We apply now the tool shell by eliminating the ends and both sides. Okay. But I didn't select, I forgot, and the edge is the motive. Double click here. 2 millimeters, not 1 millimeter. Okay. Now we have a sheet metal part, my friends, but without its tools. Oh, but we can convert it to sheet metal. Good. What is the base? You see here, select base face. To inform sheet metal part module in Inventor, what is the thickness? This is the base face. Then you see by default the thickness is 2 millimeters because we place here a thickness of 2 millimeters. Now we can use specific tools of sheet metal part environment. So, taking a look at the drawing, we see that the part has two flanges. The dimensions are placed here. 53 is this dimension to the center. The distance of the radius is 20, so we have 73 this distance. But 73 is from this end to this end. So what is the distance from this end to the face, to the external face? We can use the dimensioning from IDW. You see the distance is 45. So if we use the flange tool, we have to add 53 with 20 plus the radius, bend radius, which is the distance between these two lines, and to subtract 30. So remember, 53 plus 2 plus 20 minus 30. Not plus 2, plus bend radius, my friends. Good. Flange. This is the edge. This is the measure, and we place here that expression 53 plus bend radius. Oh, I was wrong. Bend radius. When I write here S, we have a good expression. Plus 20 in the drawing. These are dimensions in the drawing. Minus 30. This is okay. This is okay. The angle is okay. But we have to create a width different from the whole length of this edge. A not centered width. What is the reference? The reference is this. The first distance is 0 and the width is 20 twice. multiplied by 2. We try to use dimensions in the drawing, my friends. We don't invent dimensions here. Okay. Now we apply corner round with a value of 20 to these two corners. Let me use the selection, this one and this one. Okay. You can see here a cut which is specific for this kind of parts, sheet metal parts, which is by default when the thickness is 2 millimeters. This is why we changed the object from standard millimeters to sheet metal millimeters part. Now what? Well, you see here a special configuration. We used revolve to close contour about an axis like this to obtain this. Now we use another tool, which is punch tool, but we have to create a point for this, for applying this tool. The point is bottom, at the bottom on this face. I select this face, I make it sketch, I go back and I have this point. You know how to obtain this sketch automatically. You can go to options, I told this many times, and at the part we select at the sketch, not the part. At the sketch, we use auto project edges for sketch creation and edit. You can check this option to obtain that nice sketch without doing many steps. Good. Now we have a point somewhere on the part. Punch tool, which one? Oh, this one. Round emboss. This is a punch. Open. What is this? Oh. The first is to select the point. Geometry. Geometry contains this selection and an angle if we need a placement, a special placement. We don't need this. The angle is 45, half of 90. We write 90 divided by 2. The diameter and the height cannot be changed because they are in inches, and on general speaking, I have to tell you that this is an iLogic use for create such kind of dialog boxes. If you want to know more, please watch my tutorials 149, 150, 151 to see how to create iLogic procedures, which are programs, to obtain everything you want by using the Inventor tools. I let these values for the moment and I apply finish. Now we have the punch, but with dimensions not wanted dimensions. So we go back to the parameters and we see what is this iLogic creation. This is an eye feature. Take a look at my mentioned tutorials to understand what is this and everything. The diameter we want to be 12. The thickness is the thickness, but you'll see what thickness is this. Angle is 90 degrees divided by 2, okay. And the height is 4 millimeters. These are our dimensions in the drawing. Done. You see, this was changed. Now I want to measure if this is 12. I use the tool measure by clicking on the KM from Monaco. And you see this is 12 millimeters diameter. In the drawing we have 20 on this base, but we use 12 because the bottom of the punch must be 12 to apply there a hole. There is a hole here. Good, very interesting and somehow tricky, because we have to know what means eye feature diameter there and so on. I apply hole on this face with this center and the value is 12 millimeters through. Okay. I also want to apply here a fillet. I cannot do this like in normal parts. So I go to 3D model, I apply fillet, I select the edge and I place here. What should I place here, my friends? What do you think we have to place here? We have to place bend radius plus, as you can see, this is not good expression, plus the thickness and S. Now is a good expression. Okay, good. We have something here which seems to be like in the drawing. Yes, but not exactly, because you see here a radius, yes, and you see here another radius, and we don't have control about this. But the most intriguing element is that this is not a distance of the thickness, my friends. Look here, this is square root of 2, 141. This is not good. If I apply our routine of revolving here, and you can see it in my previous tutorials about sheet metal parts, then I control everything. This is a motive for me to not use this tool, punch. And another motive is this one. Look here. Now I want to mirror, yes, to mirror all these features from the flange to the bottom, to have another replica or another feature, identical one, about the midplane. Let's try to do this. Mirror 1, 2, 3, 4, 5 features. About what plane? About the plane XY. XY. Good. It seems to be okay. Okay. But it is not okay. What do we see here? We see that the fillet could not build this fillet. Cancel this, but the result is nothing. What to do? Well, we do the same thing like here, but we mirror only flange, corner round, and for you, feature. And also hole, because the problem is with this fillet. What is the plane? The plane is XY, okay, and we have something not good at all. This means that we have to not select the eye feature and the hole in our mirroring, or to eliminate them from here. This is more difficult. Control Z and mirror 1, 2 features about that plane X, Y, okay. And now we repeat the punch. This is the second and most important reason why I don't use eye features, because you have to know everything about them to use them. Sheet metal, punch tool. Where is the point? The point is here. You know the procedure. Go back, punch, round emboss. This point, if you go here, you see the already selected tool. Click on it. Size 45 degrees, and that's all. Finish. Now we go to the parameters and we change for the second eye feature 5 2 after eye feature 5 1, the second instance of this feature. This is 12 and this is 4. You see millimeters are here. This is why the dimension is finished with IN from inches. So 4 is the value. Done. We apply hole. Where is the hole? We select the face, we select the center, and the value and the through are already selected. Okay. Let's see what is the volume of this interesting part. Eye properties, physical, update, something. Copy, close, double click, blank. There is a difference here because of our road to the finish. I suppose I applied another road, another way. So I eliminate the previous value because all you have seen here was this, which means this. Now we have the part and we are happy to have it. Yes, we combined sheet metal environment with the 3D model environment. That's all for today. Thanks for watching. Bye bye, my friends.